Hey guys, we're going to go over the electromagnetic induction activity that you guys weren't able to complete on your computers because it wasn't working. Luckily, my PC was able to get the JavaScript to run it. So let's just go through the activity quickly in this video and we'll get the answers. All right, so it says hook the ammeter up. Now, unfortunately, in the new version of this, there is no ammeter. So what we're gonna do when we're looking at this, essentially it's just a simple circuit with a couple coils leading from a positive and a negative end. So it's just a series circuit with nothing attached to the coils. So when you do see those lines for the brightness of the bulb, that just means the bigger the lines, the more current must be running through these coils and therefore on the inside of the light bulb to create more power. So more current is going to be brighter lines or bigger lines. So let's keep that in mind. So 1, hook the ammeter up in series. Okay, whatever. 2, take a bar magnet. Okay, we've got that, and slowly move it towards the coil. Slowly insert it into the inside of the coil. What will the needle of the ammeter do? Or in other words, what will the brightness of the bulb do? All right, so we're going to take this and we're going to slowly move it towards, and we can see that the light bulb starts to create light. So the needle of the ammeter, what would it do? It would start moving. It would start deflecting. When is the needle of the ammeter going to deflect the most? Well, if we try to run this again, the brightness of the bulb isn't very much, and then all of a sudden it starts to get bigger as soon as that south pole of the magnet most likely reaches the south pole of the electromagnet, which is the solenoid coil. We could also flip the polarity of the magnet and try it with the north end. Well, not much is going on out here. I mean, you do see a little bit of brightness, but as soon as that north end gets on the inside, north to north interaction, the needle of the ammeter would start to deflect a lot. So whenever you have the poles being run through the center of the solenoid, that's when you're going to have the ammeter's needle deflect the most. All right, number 4, stop moving the bar magnet when half of the magnet is inside of the coil. What happens to the needle of the ammeter, or in our case, what happens to the source of light? So we'll stop moving it halfway, and the needle of the ammeter is going to rest at 0. All right, slowly remove the bar magnet from the solenoid at the same speed as it was put in. Which way does the ammeter needle deflect? Okay, let's do it again. We're going to go this way at a certain speed. Then we're going to go the other way at the same speed. So we can see that the production of the lines looks pretty similar, just in the reverse direction. The current would reflect the exact same thing on the needle of the ammeter. So the needle is going to go one way and then it's going to deflect back the other way. Okay, what number? We are currently on number 6. Okay, repeat steps 2 to 5, but this time increase the speed at which the bar magnet is inserted. How does this speed affect the deflection of the ammeter needle? Well, let's put it in again at the same speed and back out. And let's go faster. Do you guys see it get a lot brighter there? So the deflection of our needle inside of the ammeter is going to be a little bit when we do it kind of slowly, and then a lot when we do it quickly. So the speed means the amount of amps is going to go up, the current is going to go up. But it doesn't change the fact that the needle deflects the most exactly when the poles are running through the inside of the coil. All right, number 7, repeat the procedure, but this time use a different coil of wire. Move the magnet with approximately the same slow and then fast speeds as before and record your results. Okay guys, all that's wanting us to do is, instead of using this coil electromagnet setup, Maybe it's going to have us use a bigger one. I don't see an option for that on here. Oh, wait. Loop area. Ah, okay, let's change that. Let's make it 100%. And now let's notice what the brightness of the bulb is doing here. And then we're going to actually play around with it a little bit, and we're going to make the loop area as small as it can possibly be. So you'll find, and you can feel this, it might not be as visually as easy to tell for you guys currently, but when I'm messing around with this, you can tell that when you're moving the bar magnet at certain speeds, it's easier to produce a brighter bulb when you're using a smaller coil at equal speeds when you're using a small loop versus a big loop. Because when you have a small loop, the bar magnet's magnetic interaction with the electromagnetic interaction is going to create the most current flow in your copper coil and therefore give you the brightest light bulb. So that needle of the ammeter is going to deflect more easily with equal speeds in this type of a setup rather than in a bigger coil, or as compared to a bigger coil. Number 8, again, when did the needle deflect the most? I feel like we answered that already, when the poles of the magnet are on the insides of the coil. And that's going to lead us into tomorrow, which I will not be there for, but you guys will have the lab set up ready to go. So good luck tomorrow. It's using Genicon motors, which can also be, or it's using Genicon generators, which can also be used as motors if you reverse the process. So hopefully I'll be able to pop into class tomorrow during your lab just to see what's going on. So good luck tomorrow, guys. Bye.